something crazy or why this happens. But looking into it, it kind of makes sense now.
What, uphill rivers make sense now you've looked into them?
Yes.
Very good.
Because it has to do with the shape of the earth.
Okay. So, the shape dictates up and down, does it?
Down.
Oh.
But it seems due to the shape of the earth and the location of the Mississippi River, it flows the force of gravity. So it goes uphill.
So gravity
it flows
goes
upward.
uphill somewhere, does it? Somewhere along the Mississippi
Like I said,
River.
it flows against the force of gravity.
So it defies gravity then?
Yeah, there's a certain part
Seems to defy gravity because it seems there is a stronger force at play than gravity in this situation. So gravity is still there, it's still factored into it, but it's not the dominating force anymore.
Okay, so somewhere...
It's the...
Nate, come on. Somewhere along the Mississippi
go ahead.
River, there is a bit where gravity isn't the strongest force, and therefore this other something takes over and it beats. I take it works in the opposite direction to gravity, does it? In order to go uphill, does it?
Yeah, it doesn't necessarily work in the opposite direction to gravity, but its effect causes something that opposes gravity.
Right, so it's an effect of something that opposes something that isn't a force anyway. So is it two effects of opposite effects that aren't forces, that cause forces, and one of them beats gravity on a certain part, or all of the Mississippi?
So we have two forces at play, gravity and the centrifugal force.
Oh, right.
The forces are not in opposition of each other, but the effects they produce are in opposition when it comes to the Mississippi River.
So it's an effect equalization, is it? Or no, it can't be an equalization because one of them's beating the other, isn't it?
Yes.
Right, so at a certain part, where is this part? Can you pinpoint it for us?
I don't think you can pinpoint it to a certain part in the river. I think it happens all along the river. It would need to happen throughout the whole course of the river.
Gravity doesn't work anywhere along the Mississippi
Along the
River.
length of the Mississippi River.
Never said gravity doesn't work.
There's another
along the
effect
Mississippi River
at play along where the Mississippi River goes that cancels out the effect of gravity and causes the water to go uphill.
Uphill.
It doesn't cancel out the effect of gravity, but it's stronger than gravity. If it removed the effects of gravity, that water would start floating. It wouldn't stay on the ground.
Right, but it does make it go uphill. So just releases a bit of the effect of the gravity by the counter effect of what are we calling it? Did you call it the centripetal force? Did you?
It goes from being 1G to half a G, doesn't it? On the water in the Mississippi.
Yeah, but that wouldn't. That still half a G would still have water finding its own level, wouldn't it?
I would have thought so.
It would. You would have
That's
to
not what
have
I'm saying at all.
negative G to counteract the water finding.
That's not what I'm saying at all.
Is it not? Please clarify what you were saying then, please.
So let's say gravity is exerting a force on the water.
It's not.
Isn't it supposed to be 1G?
Gravity is exerting 1G on this water. newtons because I'm comparing two different forces to each other, and we can measure all forces in newtons.
Yeah, but gravity isn't a force.
Yeah.
Of course.
Bit of a
Don't
problem.
forget, gravity isn't a force.
Are you gonna say it was superseded by Einstein? No, it's still a force.
Yeah, it's not a force.
Even
It's
in
a pseudo force.
so gravity is maybe releasing 10 newtons of force on the water.
Maybe.
The centrifugal force is releasing 20 newtons. So it doesn't mean all of a sudden gravity's newtons become 5 or half a g. It still stays 1 g, but this other force is exerting more energy
It's like
into the water.
Twice as
Right.
much. You just said. The centripetal force that you just called it then was twice the amount of gravity.
Centrifugal.
How? Yeah.
Centrifugal.
How does that manage to keep the water from going downhill if it's twice as much? The centripetal force. It's twice as big as gravity. How? Please.
Because that force is exerting more energy into the water.
Newtons. You just said it was one
So
was
it
10
will-
newtons and the other one was 20.
Yes. So one force is exerting more energy into the system.
Not newtons then. Is that not your measure?
So Newton's measures a force, but when a force acts upon you, it releases energy into you. That is why forces make matter move. Because they induce matter.
Yeah, but one of them does twice as much as gravity, right?
Yes.
And it's in the opposite direction. So how does gravity win?
Gravity wins because it keeps the water its stream. It doesn't let the water float in the middle of the air. It keeps it on the ground.
Yeah, but it's well known that even if gravity was a force, it is the weakest force. So how can half the amount of the weakest force supersede twice the amount of a stronger force?
Well, in this situation, it's not superseding the other force.
Well, it must be for the water to be held in its track in the stream.
Downhill.
Because the other force is not dictating whether or not water stays on Earth's surface or floats in the air. This other force is only dictating what direction the water will flow in. Gravity in this situation is only dictating whether the water stays on the in its stream or floats in the middle of the air. Normally, because of this, water will flow downhill.
Yeah.
The particles are being pulled down. But because the centrifugal pseudo-force is way stronger than the gravitational pseudo-force in this specific situation, the centrifugal pseudo-force will dictate what direction the stream flows in.
Right, okay. I've got one for you now. You seem to have got that straight in your own head, although it is confusing. It is really confusing. Okay, so for this to be an effect, that means that the Mississippi must flow at a constant rate from the source to the mouth. There can be no... It has a 1 in 3 drop. There can be no steeper drop. There can be no 1 in 4, 1 in 5 drop.
Are you saying the slope must be constant?
It must be
throughout?
constant. It must be constant. Going faster, there is more weight of water behind the faster flow of water. If there's more weight of water, your theory has just sunk.
I don't know about it needing to be constant, but I know the reason the theory works out is because when you look at the distance of the mouth and the source from the center of the Earth, which is what determines your gravitational effect or how much weight you have.
How far away you
How
are
from
from
the center of mass.
the Earth?
Center of mass.
Yeah, it
We see that the
makes you heavier.
mouth of the river is further away from the center of the Earth than the source.
And that affects, you being further away from the center of something does what does
Determines your weight.
that? Right.
How much gravity
You
affects you.
get heavier. In
Way
which
more,
direction?
yes.
Which direction?
In the direction towards the center of mass of the other object. Way more than astronauts on the ISS, for example. Closer to the Earth's center. So technically, objects at the equator weigh more than objects at the pole, because when the Earth spins, it becomes an oblate spheroid, stretch out and move further away from the center. And that is where the Mississippi Ocean's mouth is closest to, the equator.
Isn't that the
While
other
its
way round?
source is
Isn't that the other
closest
way?
to the pole.
Isn't that the other way round? That you weigh more at the poles than you do at the equator because centripetal force is throwing you outwards.
Oh, did I say you weigh more at the equator? My
Yeah.
bad. Thank you for correcting me. You weigh more at the poles than at the equator. My mistake. So yeah, okay, so exactly what you said. What you said is it. Because the centrifugal force is throwing us off, things closer to the equator weigh less, are affected by gravity less, and are further away from the center of the Earth. So the Mississippi
So
River.
you shot yourself in the foot with your argument about the Mississippi, because that means the effect of gravity would have to vary along the course of the Mississippi because the weight of the river remains constant. So your
Yes.
centripetal gravitational effect has to vary along the course of the river.
Might. I haven't looked into that. That is a good point you're bringing up. I don't know how it would impact it. I'm sure the forces would vary. What you're saying is right because it's not smooth and constant.
And
it would vary.
The other thing you have to make sure of that there's no rapids, that there's no waterfall, that there's no area where the water's in free fall.
I doubt the Mississippi River has that though.
Oh, I really don't know. I'm not American, so I don't know.
I've never seen any of that around the river. But these are good points that you are bringing up, which I need to go look into, and I will be back tomorrow to answer those. But this is what I've found and understood so far.
No, but you understand everything that you brought up is still begging the question. It's still begging the question of a ball. It's still begging the question of gravity. It's still begging the question of a ball with a center that generates a magnetic field.
Maybe, but I'm not trying to prove the shape of the Earth to you right now.
But
someone asked me if I've figured out how the Mississippi River thing works, and I'm just giving them the answers that I found.
Yeah, I understand that, but you are still begging the question with the answers that you've found.
Is it because my answers work only with the Earth being a sphere?
That your answers involve forces that are not real. That your answer involves the shape of a oblate spheroid that's not real. And you need to prove those things exist before you can justify the answers that you've come up with the flow of the river. Otherwise, you're just begging the question.
Yeah. I mean, listen, if you don't agree with if you have your own explanation, I'd love to hear it. But that is what makes sense to me.
I have an explanation. The source of the Mississippi is higher than the mouth of the Mississippi, and it finds the path of least resistance between the two. Hey presto, you got a river that flows downhill. It's easy.
The Mississippi River flows uphill. Are you saying it flows downhill?
I'm saying that water flows downhill.
Right.
And the only reason that you've given me that the Mississippi flows downhill is because you are saying that the mouth is further away from the center of your begging the question ball than the source is away from the center of your begging the question ball. So therefore, your argument or your reasoning of why that particular statement might be true is begging the question.
Okay.
I don't need to beg
Let's
that
assume. Okay, that's fine. That's fine. I totally give you that. Let's assume we don't know the shape of the Earth, what the shape of the Earth is, right? It's been
Is that you, Ben?
experimentally and factually proven that at the equator, sea level is higher than at the poles. That's a fact.
Where?
That doesn't tell us what the shape
Sorry,
of the Earth
sorry,
is,
sorry,
but that's
wait
a
a minute.
fact.
You say a fact. How? What are you talking about?
How was that
At
proven?
sea level at the equator is about, on average, 21 kilometers higher than at the poles.
How?
That doesn't tell us the shape of the Earth.
No. How do you know that? Please.
It's been measured.
Measured? How?
How?
Do you measure sea level?
Right. Okay. So let's just take it as a
What do you mean?
logical.
You don't need the shape of the Earth to measure
Nate,
sea level.
Nate, right. Okay. So you're at the North Pole and you are heading towards your South Pole, right? So let's just say you're at the north and you're heading south. Now, do you rise to a big lump? Are you going to get on your boat, go on the water, and head up hill 20, how far? 21 kilometers, is it? Yeah.
Mm.
Do you go uphill
That's
21
exactly
kilometers?
what's happening.
That is exactly
Yep.
what's happening.
When people sail from North America to the bottom of the continent, they're sailing uphill.
And downhill.
That's a
again.
fact.
Uphill and downhill.
When I'm sailing from New York to Florida, I'm sailing
let's just go from
uphill.
the north to the south, right?
New York to Florida, north to south.
No, I
I'm
don't
sailing
know. That
uphill.
doesn't mean anything. I'm going to go from where Polaris is to Australia, let's say. Yeah?
Oh, that would be okay.
Right, and then am I going to go in my boat? Am I going to go uphill 21 kilometers to the equator and then go downhill to Australia, to the south?
Yes.
Yes. That makes complete
Nate,
sense.
Nate, you do realise that, from what you are saying, that when you are at the equator, you are 1/4 of the distance to the Kármán line.
Yeah. Do you know, like, as
you
you're going
are
on your boat,
you are
Everest.
you are actually almost 3 times higher than Mount Everest
At the equator.
at the equator.
Whilst
Do you know how ridiculous that is?
Saying it all though.
It is. You've just said it.
I've said sea level.
Yeah. Rises 21 kilometers.
Yeah, is different from one to the other. Mount Everest does not start at sea level.
You know, it's 8.
Does it?
8.8 kilometers above sea level.
Yes, but exactly above sea level.
Yeah, well, you've got the sea
hold on.
level
What about-
altering 20,
21 kilometers. Your sea level starts over twice the distance that the top of Everest is away from sea level.
Yeah, so when they say Everest is
I understand what you guys are
8,800
saying.
meters above sea level, they mean
Above sea.
Everest is above sea level at the North Pole.
No, it's above the equator sea level.
No, it can't be above that. sea
No, it
level.
is above.
No, it
It
can't
is.
be.
It's
It
got
must
to be.
one-
It's
no.
got to be. It's closer to the equator, so it's got to be above the equator sea level.
But then it would make Everest at
Almost.
21.
That would be
plus
almost
8,
touching.
like 29 kilometers above sea level, wouldn't it?
So that is.
Oh no, because 21 kilometers is 0.
My head.
Yeah, but that sea level's higher than the other sea level, isn't it? So which sea level are we talking about? That's a good point, Nate. When we say things are higher than sea level, which sea level do they mean? The one at the north, or the one at the equator, or the one at the south, or somewhere in
Sea
between?
level varies, right?
Yeah, but they got MSL.
So I think
you
they
know,
should-
you know what MSL is?
Yeah, but hold on.
Mean sea level. So is that the mean distance between your 21 kilometers and 0 kilometers?
If they all vary, then why are they all 0 on the Google Earth model?
That's a
They're
good
all
point.
level because they're all level.
Well, they're not, because if you're saying they're from the center of the Earth and it's the same distance to 0, then that would mean that they would all be 0, the same distance from the center of the Earth.
And,
But they're
okay,
not,
those are
because
things
of the
that- those are
equator
things
is
I've been
21 kilometer.
Yeah, on your
Different.
model, Nate.
Okay, so what I've said is sea level at the equator is 21 kilometers higher than sea level at the poles.
Yes.
Sea level varies all over the world. It's not constant, but
Well, why
It's
does
not
it say
level.
0
oceans
then?
remain.
Why does it say
Why
0?
does what say 0?
Well, if you go on Google
What says
Earth,
0?
go to Google Earth, and
Uh-huh.
I'm going to do it now.
Mhm.
I'm going to check myself.
Check
That's all.
yourself because I'm not sure what you're talking about.
Yeah, so when I've put the cursor anywhere in the world on the water, it's always 0,
Yeah,
right?
that specific spot will be 0. But if you compare it to sea level somewhere else, there'll be a difference in elevation.
No, it'd
But
be
the
0.
oceans always remain level.
No, it'll always be 0.
All right, so let me say it again. If you look at sea level at one specific spot on your cursor, it'll tell you 0. But if you compare sea levels at two different places, there will be a difference in their elevations, right? Because the Earth, even you guys agree, has ups and downs.
But that's
Even
not.
if even if you feel
Yeah, but I
there
don't think
is a curvature, you
I
got to
think
admit
water.
it's not 100% flat,
The only ups and downs
right?
in water is waves.
Yeah, tides and waves.
Is the only ups and downs on water.
Yeah, not
Okay.
water isn't like like higher than somewhere else by any more than the tide.
Can I just add here, Nate? Like, when you see water, do you think the water conforms to the underneath of the container, the surface? Does that conform to the underneath of whatever's the water is?
Ask that again, then.
Well, the top of the water, the surface of the water, right? We call that level, right? Now that always
Yes.
is level, meaning horizontal, no matter what the shape of the container, right? Do you think that the water level conforms to the shape of the underneath of the container?
You're asking, do I don't understand the question, bro.
Well, but basically, we're dealing with the word level, which means to us horizontal. Now that's a straight line. Would you agree with that? Or is that where we're getting stuck?
You're asking because of the terrain at the bottom of the ocean and the difference in elevations in that terrain, does it affect the sea level of water at the surface?
Yes. What shape would you put to that level at the top of the water?
Shape.
I don't want to lead you by giving you a shape to go for.
Man.
Is your mic gone? Or you
I
give
don't
me
think he doesn't understand the question. I think.
I don't understand the question.
so
Can you explain it differently?
Or maybe you have a diagram that could.
a diagram of what water level is. You want me to bring that up again?
Oh, what it is you're trying to ask me.
Okay, right. Well, if I show you the tool, a water level, right? Here's description going in the chat there.
Oh, I was just about to give him that as well.
And then here is the actual
Yeah.
tool. Yeah, nice one. Right, so the
water
tool
level.
is just a tube with little plastic things on the outside of it.
Hmm.
And then, so if you can imagine that big long tube, imagine it really long, like a 2-mile hose pipe. And then you fill it up with water. You see that? And then DP's done a
All right.
nice.
I
really
see
cool
you.
meme.
Okay.
So it's the horizontal plane that goes from one to the other.
That one. Sorry.
Can I ask you a question? If I take that water level, right?
Yep.
And I take the side on the right.
Yep.
And I push it down a little bit. Not the water in it, but the column itself. I push it down a little bit.
Yep.
Saying that what would happen is water in that column that I'm pushing down would rise up the column till it is level again with the water on the left-hand side.
Yes.
You're right. Well done. Yeah.
Yes.
Do you think we could make a scientific experiment out of that? Do you think? Would that be
No, I just wanted-
manipulating a variable, like moving that thing on the right? Do you think?
That would be science. Even though this is a man-made tool, it is science. Yes, it's natural.
Brilliant.
Right, Nate.
I totally agree with you.
I've got a question for you, Nate. Right. You got the two vials at the end. Yeah. You got the hose in the middle. It's approximately 2 miles long. Yeah. So you hold the vials next to each other, one in your left hand, one in your right hand. They are level. The water in the vials is level. Yeah? You with me?
Hmm?
Okay, you give one to your mate. Your mate walks 2 miles away.
Hmm?
Are they still level?
My
Can you-
mate takes one of the vials and walks 2 miles away to the left or to the right. Yes, they would still be level.
Right. You can still get
Now-
them to level.
So let's say now, looking at those columns, right? Water is like at the top. Let's say the reading of that was 2 inches. Both of them read 2 inches, right? Now, if I push the column on the left down 1 inch, in order to remain level with the column on the left, would now read 3 inches, right? So the column on the the column on the right that I pushed down 1 inch would now be marked off at 3 inches. That's where the water would be. So I've pushed column right down. The
Hold on,
water
2
marks
seconds.
off at 3
Hold on.
inches.
Hold on. Just can you say that again, please? Because
I'm
what
having
you
a-
said,
I'm having a job
So
following him
if
as
you-
well.
if you got those two, one on the left, one on the right, and you lowered the one on the right, right? What do you think the water would do? Would it stay in the same
No,
position?
it would go up. It would go up so that they remain level.
You're only moving. You're only moving one end of this water level, right?
Yes, I'm moving the right one down
Yeah, but what I need
by 1 inch.
what I'd like you to just answer to me is so let's just say that the one on the right, let's just say that was that actual bit on the end, which is the measuring tube, yeah, that's see-through, and you can see the water in there, and it's a meter long, yeah. Now if you move that tube up or down, either way, do you think the water would move inside of the meter tube?
Yes, the water would move because it wants to remain level.
No, the water will stay exactly where it was. The water won't move. Only the plastic tube will move. Do you understand?
Right, maybe-
That is a fact. There's no maybe.
Sorry, hang on. I'm getting a phone call.
Yeah, no worries.
I'm just gonna mute myself.
Good afternoon, everyone.
Yeah, you're right, Spot. How you doing, mate?
Good afternoon.
Oh, and is that Hyperborean as well? No, it's Cypher.